solenoid. As many of us already know what is a solenoid. It is a current carrying wire, or you can say it's a current carrying cylinder rather than a wire. It's a current carrying cylinder which is hollow, and we would wound a current carrying wire around it. So the current moves from here and comes out. This is the current I, and the length between these two is L. So length of the solenoid is L. The radius of this solenoid, suppose this is R. So this is a particular cylinder, hollow cylinder, which is wounded with a wire which is carrying a current I. The length is L, the radius is R. For this particular solenoid, not only for this particular solenoid, for all the solenoids to work properly, the length has to be much greater than R, which is the radius has to be negligible when we compare it with the length of the solenoid. Now, what is this particular solenoid do? The solenoid, because there is a current flowing through this wire in a particular fashion, this would produce a particular amount of magnetic field. So if we want the desired magnetic field, we would be able to change the different factors of the solenoid to get a particular magnetic field just by using the current. So for a solenoid, inside the solenoid, magnetic field will be mu naught N into I. Now this I would explain. What is N? Before going to N, now just suppose that this wire has N turns, capital N turns, right? So this particular wire has capital N turns, and the turn per unit length means capital N by L is the number of turn per unit length. So this is turn per unit length, and the magnetic field inside, I can write Bi for a solenoid, which is mu naught N into I. So just by controlling the current and just by controlling the number of turn, I can produce a desired magnetic field inside this solenoid. Same way, if I want a magnetic field at one of its end, so any one of its end point, the magnetic field B, suppose it end point, it becomes mu naught Ni by 2, that is just half. So any one end point, the magnetic field is mu naught Ni by 2. So you see, using a solenoid, just by changing the current and just by changing the turn, we can produce any amount of magnetic field or any desired amount of magnetic field that we want. So that's how solenoids are of very important use in producing magnetic fields. Similar to solenoid, toroids are another very important of use in our producing magnetic field. So in solenoid we have a cylinder, hollow cylinder, whereas in toroid we have a circular cylinder or a circular hollow cylinder, and through the toroid, the current would pass. The wires are wounded around the toroid like this fashion. So the current is entering, same way it is coming out. So this is the toroid, and Suppose same way, there are n number of turns and N by L is your turn per length, right? Then the magnetic field produced by the toroid is mu naught Ni, right? So just by controlling the current and by the number of turns, we can produce a desired magnetic field. Very important to know, even when we talk about solenoid and the current that is moving and moving out, and there is a production of magnetic field. In case of solenoid as well as toroid, their radius of the cylinder, the length of the cylinder, or in this case also the radius of the toroid, actually doesn't much affect the magnetic fields, right? So therefore, just by controlling the current I and the number of turns, we can produce our desired magnetic field. And that's how solenoids and toroids are very much of use when we talk about electromagnetic effects.
If you like the video, then press the like button, subscribe to the channel and press the bell icon.